We're going to solve by completing the square when we have an equation that looks a little bit less friendly. But we'll see with some nice manipulation that we can get it to look perfect. So remember, in order to complete this square, we should have an equation that's in the like a quadratic that's in the form of something x squared plus bx plus or minus something, or equal to a constant. The important thing is that we have an a term equal to 1. In this case, the a term is equal to 1/2. So we're not going to be able to complete the square as is because the a term is 1/2. That's okay, because what we can do is we can get the a term to be, let's change our focus there. We can get the a term to be 1 simply by multiplying every term on both sides by 2. So z squared over 2 times 2 is simply z squared. Z times 2 is 2z, and 2 times 1/2 is 1. Now, this still isn't in the form x squared plus bx and some constant over here. So all we need to do is bring this term over. So we have z squared minus 2z is equal to 1. This way, we recognize that this constant term is going to stay on this side, so why bring it over just to come back out again? So to complete the square, we're going to take half of this b term and square it, and then add it to both sides. Z squared minus 2z plus 2 over 2 squared, which is simply 1, is equal to 1 plus 1, right? Because these two terms are equal. We have a perfect square on this side, so z plus 1 squared is equal to 2. We take the square root of both sides. The square root of z plus 1 squared is equal to plus or minus root 2. We're left with z plus 1 is equal to plus or minus root 2. We cannot take the square root of root 2. 2 is not a perfect square. What we have left to do is take this 1, bring it to the other side. So we have z is equal to negative 1 plus or minus root 2. Remember, anytime we have the root, it's customary to keep it second. So that's just why I put the constant 1 here. We could break this up and we could say negative 1 plus root 2, or equal to negative 1 minus root 2. Let's see.